In this video, we will look at considerations for implementing real-time analytics using the SAS Intelligent Decisioning solution. But first, let's think about some of the drivers. There is a growing demand for integrating or embedding the analytics into business processes as more and more organizations want to become data-driven. We see this in requirements for streaming analytics or decisioning. To meet this demand, SAS has a number of solutions, but in particular the SAS Event Stream Processing and SAS Intelligent Decisioning. Some customer examples of applying these solutions include personalizing next best actions across all channels, real-time contextual data for web interactions to personalize messages, serving targeted offers to customers, for example discounts to high-value customers, and embedding rules in decision flows or scoring. We will focus on SAS Intelligent Decisioning and the SAS Micro Analytic Service in this video. But first, if we take a step back and have a look at the Viya platform. This provides a conceptual view of the Viya platform. And along with the analytical engines shown on the left here, we can also see that there are other logical groupings of components and services. We have our programming runtime, our infrastructure servers, and our services, which we categorize as microservices and web applications. When we're thinking about the SAS Intelligent Decisioning and the processing engines associated with that, the SAS Cloud Analytic Services, or CAS server, is used for batch processing. And as we'll go through and look at here, the SAS Micro Analytic Service is used for our real-time processing. So if we have a look at the lifecycle and the core applications that interact with MAS, or the SAS Micro Analytic Service, we have this illustration here. Across the top, we can see the 4 key phases of the lifecycle. In the create phase, there are a number of tools that you can use to create the models and decision flows, which are highlighted in green here. You can also use SAS Intelligent Decisioning to create those models and decision flows as well. Once you've created this, you need to be able to deploy it. You can deploy the decision flow with SAS Environment Manager, SAS Intelligent Decisioning, or SAS Model Manager, which are depicted in the blue boxes here. Once the model has been deployed, it's ready for a business application to consume. And in the right hand side here, we can see the call or act phase where the business application is calling the SAS Micro Analytic Service, which is represented in this execute phase. There are 3 logical layers to the SAS Micro Analytic Service. We have the REST API, the REST layer. There is a Java layer which is depicted by the Micro Analytic Score service, as shown here in grey, and the core engine or underlying MAS engine. The Micro Analytic Service, or MAS, is provided with a number of SAS solutions, particularly SAS Intelligent Decisioning and SAS Model Manager. The core engine is also provided with SAS Event Stream Processing. Now let us discuss some architecture considerations for implementing real-time analytics. The availability and redundancy requirements are key inputs into the design. It is important to understand the end-to-end requirements and not just focus on the SAS components. For example, what integration pattern will be used? Is integration via a services bus, message broker, or will direct REST API calls be used from the business application? System response time and latency become very important when integrating with online systems. The integration with the analytics platform should not make the calling application run slow. We need to consider this when developing the models and decision flows. Are all the inputs for running the model or decision flow passed on the API call, or does the model need to reference other external data, reference data? Another consideration at execution time is, does the model or decision flow need to write out data? We also need to understand the supporting batch requirements versus the real-time runtime requirements. What are the software development lifecycle environment requirements? Is strict separation of development, test and production required, or can these use a shared platform? There are many other concerns that we also need to look at, for example security, authentication and token management, or storage. Is shared storage required for the analytics store? And many more. Now let us discuss some of the how. In developing the deployment architecture, we need to consider the SDLC requirements as I've just mentioned. Is separation of the design, which is development and testing environments, from the runtime platform required? What is the approach to availability and recovery? Is there going to be a shared production platform for batch and real-time, or do these need to be separated? The batch processing is typically run on the SAS Cloud Analytic Services or CAS server, and the real-time processing uses the SAS Micro Analytic Service or MAS. So let's have a look at this in some more detail. If we look at batch versus real-time processing, on the left here we can see that the batch and interactive processing is supported by the CAS analytical engine. There's very little or no use of MAS in this environment, where the real-time processing is supported by the MAS server. I've also put a question mark in here on CAS because it is possible to call the CAS REST APIs. But within the context of SAS Intelligent Decisioning, the real-time transactions are all supported by the SAS Micro Analytic Service or MAS. It's important to understand this when it comes to sizing our deployment. If we're looking at the batch and interactive processing versus the real-time processing. Now let us discuss some deployment patterns. The first pattern I'd like to discuss is having a shared platform. This is using a single platform for the design or development environment and the production runtime. If you're taking this approach, MAS can or should be installed on separate servers which are dedicated to that service, to provide some level of isolation for the real-time transactions from the other workloads running in the system. If we look at some of the advantages of this approach, it's a single platform to operate and manage. There is a single step to publish that decision flow into MAS. Some of the disadvantages include the development and production environments cannot be independently scaled. There is no separation of workloads, so it may be possible for the interactive workloads to impact on the real-time processing, and there's no separation of internal services given that it's a shared platform. So what does this look like? To illustrate this, you can see on the left here we have our application server, if you like. It's my server running SAS Intelligent Decisioning, but it may also have a number of other SAS analytical products running on the platform. For example, Model Manager or SAS Data Mining and Machine Learning. This is running my visual interfaces and programming services, and I create my decision flows and models here. I then publish the flows into the SAS Micro Analytic Service. As shown, the SAS Micro Analytic Service, or MAS, can be scaled horizontally, so I can have one or more servers running here. When scaling out like this, I need a shared file system location for the analytics store, the A store data. And at the top we can see we've got our end users of the visual interfaces and programming, for example SAS Studio, accessing the platform and through here, and our business applications calling the MAS service is also coming through here. So that is the shared platform. Now let's have a look at the second pattern, having a separation of design and the runtime environment. This is probably the most common pattern that we see. So we end up with a platform which is dedicated to the design or development, and one that's dedicated to running the real-time or production environment. The development platform may have additional products installed on it, and this could be our general analytics or discovery platform. And it's the recommended approach to isolate the runtime from general analytics workloads. So again, if we look at some of the advantages and disadvantages, for this pattern, one of the advantages is separation of the workloads and internal services. Given that we have separate platforms, they can be scaled independently, and we can apply different service levels to each environment. Typically, their runtime environment would have the higher availability requirements. Some of the disadvantages, we have multiple platforms, so there is more work to operate and manage the platforms. The models must also be transferred between environments prior to publishing to MAS. This could be just part of your change management process. Now, if we look at what this looks like, again, illustrating it here on the left, we have our development and design environment. And as I say, this could be your general analytics platform. So we have SAS Intelligent Decisioning, but we may have a number of other products installed like Model Manager or Visual Data Mining and Machine Learning. In this environment is where we're actually creating our models and decision flows, and then we will export them into the runtime environment, which is shown on the right here. In here, we just have the minimum products required to run those decision flows and models. For example, we've got SAS Intelligent Decisioning again. We import the decision flows into here. Once they've been imported, we can then publish them to the Micro Analytic Service. Again, we can see that we can have one or more microanalytic services deployed within the environment. As we've got this multi-server environment, a shared file system location will be needed for our A store and analytics store. As you can see, it also illustrates that the end users accessing the visual interfaces and programming interfaces directly access this platform, and it's separate to our calling business applications, which are calling the REST services over here. So we have a nice separation of the network traffic as well. The third pattern that I'd like to discuss is using a high availability configuration. Given that the runtime platform or the analytics are being embedded or integrated with business processes and applications, this typically means a higher level of availability is required. The Viya platform components can be clustered to provide a high availability configuration. Resources can be dedicated to functions or roles. We've already seen this when discussing the CAS or MAS processing. But the stateful services, microservices, and web applications can also be independently scaled. To implement a high availability configuration, a minimum of 3 servers is required. You may use more depending on your requirements. Additional OEM components may be required, for example, front-end load balancers or proxy servers, and as we've already seen with scaling mass, shared storage may be required as well. This is a more complex configuration to maintain and manage, but the use of a high availability configuration should be driven by your business requirements, the availability requirements. So if we have a look at this illustration here shows the logical tiers or grouping of the different components. What you can see with the square bracket notation is the host groups that would be used during installation. We can see the stateful services and dependent services that are required for running the Micro Analytic service here on the left, and we've scaled those out with 3 servers. There are a number of other microservices and web applications in the platform supporting the visual interfaces and the environment. You may or may not need to scale these out depending on your requirements. We've already seen how we can scale out the mass server. We're also showing here that the HTTP proxy process could be deployed on separate servers as well. In the middle, we can see the need for shared storage again for the A-store files. And finally, at the bottom here, depending on your batch processing requirements, you may need to scale out and provide some redundancy for the CAS server. And this is shown down here. As I said, the minimum requirement is to have 3 servers to implement a high availability configuration. But depending on your availability and recovery requirements, this will drive the number of servers that you use. However, there is more to the implementation than just deploying the SAS software. Calling the REST API is the easy part. For example, I created this auto auction decision flow as part of my testing, and this is how I call it. The first part here is calling the service, and we can see the Micro Analytic Score modules, followed by the decision flow execute API, so my auto auction decision flow. However, the end-to-end application business logic needs to be designed, including the transaction retry and recovery. For example, what happens if the response from my auto auction decision flow is too slow? Does the application time out? Does it retry? What are the recovery logic in here? What error message might be presented to an end user, for example, if they were filling in a form? You need to deploy and configure the platform to meet the availability requirements and other non-functional requirements, for example, your security requirements. As we've seen, shared storage may be required depending on the deployment topology, especially for the A-store storage. And there are administration and configuration activities as well. The client or the business application that is calling the MAS API needs to be registered with the Viya platform. It needs an OAuth access token and refresh token. The access token is used as part of calling that MAS REST API as part of the authentication process. Additionally, if we have got separation of our design platform from our production platform, the Viya transfer CLI can be used to deploy the decision flows between these environments. So, in conclusion, when dealing with business critical systems, the integration needs to be carefully planned and well designed. It is possible to build a robust, high availability configuration and to scale the Viya platform. SAS Viya provides APIs and solutions that enable the integration of analytical models and business processes and rules. SAS Intelligent Decisioning and the Micro Analytic Service provide rich functionality. There are also other solutions like SAS Event Stream Processing available. Thank you for watching, and I hope this was helpful.